All right, we're going to go through this one relatively quickly so that I can get us onto pre-bronze today. We've got a lot to cover. So, this is a conflicting viewpoints passage, and remember, this is the last time that I was going to tell you which ones you were dealing with. So, it is up to you. All right, number one. Number one, the discovery that many tektites contained unmelted crystalline material wood. So unmelted crystalline material, wood. And then we need to find, that's our key term, unmelted crystalline material. So, here, non-local origin is extremely unlikely given the narrow distribution. The next time its orbit coincided in the Earth. Tektite. Tektite. Talking about tektites, but we need to find the words crystalline. I don't see that anywhere in Scientist 2, so let's look at Scientist 1. And tektites never contain unmelted crystalline material. So, what if we did find that? That's going to weaken Scientist 1 because this says it never contains it. And so if I got that question wrong, this is the quote that I am putting in my how do you know the answer is correct. I did not underline that well, so I'm just going to fake highlight it. Okay. Number 2. Which of the following is a reason given by Scientist 2 for believing that tektites originate on Earth? So, what do we say? Non-local origin is extremely unlikely. Narrow distribution of tektite fields. There are striking similarities between the composition of the Earth's crust and that of most tektites. Okay. And then it says something about meteorite impact. So, density of the Earth. Didn't it say density? So, maybe not. F. It did say that the atmosphere was similar, but it didn't say that. Tektites have a composition totally unlike that of any other material. Doesn't say that. Extraterrestrial material could not have been widely dispersed as tektites are. It doesn't not mention that, so it does say that the local fields get in the way. Material ejected from the moon or beyond would eventually have been much more widely distributed. So that looks like our best answer, because that looks like here. The next time it coincided with the Earth, it would be captured and fall over a wide area. So the key terms match here. So anything circled in yellow or in orange would be what you used as your quote for J. Scientist 1 could best answer the point that some tektites have vesicles filled with gases in the same proportion as Earth's atmosphere. So why do we have things that are similar to Earth in Scientist 1? I'm going to go to Scientist 1. Let's see. Analysis from the lunar mission strongly resembles some of the tektites from the Australasian strewn field. Tektites only contain a small fraction of water. The otherwise similar by some meteor impact. Okay, so here we go. They're formed from the moon. Atmospheric forces keep them from being from the Earth. Because of the density, tektite-like material ejected would never attain a velocity high enough. Most likely, tektites were formed from meteorites or from lunar eruptions. So, Scientist 1 could best answer. So, countering that not all tektites have such gas-filled vesicles. This is like, sure, you could say that that's not all that, but that's a weak response. So, your answer is not going to be A, because that's like being like, sorry for that awful sentence just now, but that would be the same thing as saying, well, like as an excuse, like, I didn't cheat on the test. Why didn't you cheat on the test? And just saying the same thing back. So it doesn't really help. Demonstrating that molten material would be likely to be trap some gases. That's a pretty good one because it talks about molten material, which is what we're talking about when it talks about volcanoes and meteorites. suggesting that those gases might occur in the same proportion in the moon. That's the same thing. These two are like they're cop-outs. That's a like, I know you are, but what am I type of response. Showing that similar vesicles are found in terrestrial volcanic glass. That doesn't really help us because we don't want to say it's from the Earth. So the answer is B. All right, how did scientist 2 answer the argument that tektite-like material ejected from the Earth could not reach a high enough velocity relative to the atmosphere to undergo? By asserting that, so how would they deal with that? So, meteorite impacts, the shock wave produced by could displace the atmosphere. So what they're saying is if it came from the meteor, the wave that would happen would like negate the problems from the atmosphere. So shock wave, that's a key term that matches. No, doesn't say anything about gradual changes. You don't want to attack the other scientist. The other scientist is allowed to be right. You're not going to attack them. And the Ivory Coast and Ghana have nothing to do with it. So number 4 is F. All right, the point of subjecting lenses of tektite glass to a heated airstream was to, so lenses of tektite gas to a heated airstream, let's see. Why did we do that? Air friction melting. So, two tektites are extraterrestrial. Their forms show the characteristics of air friction melting. So why did we do that? Determine their water content, not what we want to see. See if gases became trapped, no. And so it's going to be one of these two. And so that's what we were trying to do in the experiment. That's going to be C, because that's how we wanted to know. We wanted to know where they came from. And that's the one that says where it came from. All right, number 6 and 7. Researchers could best counter the objections of scientist 2 to scientist 1's argument by discovering some phenomenon that would quickly. So, scientist 2 to scientist 1. So, why would scientist 1 be, or scientist 2 be wrong in this one? Discovering some phenomenon that would remove them from orbit. Proving the most common tektite shapes are produced by aerodynamic heating. Confirming that active volcanoes once existed on the moon. So we're saying that these are from... So scientist 2 says that scientist 1 is wrong, and we want to counter that. So scientist 1 here, or scientist 1 says the reason that they're wrong is because that atmosphere has to get displaced, and then they go into orbit. Right by the atmosphere would remain in a solar orbit. So all we have to do is get them out of orbit, and that will prove him wrong. Key terms. That's our match. And our last one. Which of the following characteristics of tektites is least consistent with the theory that tektites are extraterrestrial? So that's scientist 1 equals wrong. Low water content, flying saucer shapes, narrow distribution, absence of unmelted material. So least consistent, let's see. So they're extraterrestrial. So what is this person talking about? So they would have flying saucer shapes, low velocity, meteorites. Tektites only contain a small fraction of water. Tektites never contain unmelted crystal material. So, low water content was mentioned in scientist 1. Flying saucer was mentioned in scientist 1. Absence of unmelted material was all mentioned. That is not mentioned. It's not in our passage, so our answer is C.